In today's episode, I want to initialize our testing experience. As you may have heard, testing is a pretty good idea, so let's set that up now. The Bitcoin software makes heavy use of the Boost testing framework, so let's use that. Let's start by ensuring that we have the source code for today's lesson. Open your terminal window centered on the CoinKit directory. Next, let's open the Docker file and observe the following changes. This installs the development edition of all the Boost libraries. As mentioned in a prior lesson, we can't just pick and choose which sublibraries we want. It's all or nothing, but that's just not a big deal, and we won't fret about this further. Exit the Docker file, rebuild the image, and run it again. Remember this outrageous command to run the image that we learned in the prior lesson. When we run the image, we start off in the container's root directory. Let's change that. And let's take a peek at our source code. Ta-da-da! Looks familiar. But if you look around the file system, you'll see a few changes. We're going to mirror the Bitcoin file structure as closely as we reasonably can. So we're going to copy files from it one by one as we discover purpose, necessity, and desirability. Today we'll initialize a small piece of this. src is where we're going to put our source code. src test is where the tests go, and src util is where some utility functions live. We start with src test base64 test.cpp. Why this test?
Why not?
Actually, we start with this test because it's the smallest, simplest, least entangled with other dependencies that I could find. As you may know, base64 encoding is a scheme to convert binary data into a form that's more easily represented as text. For example, maybe the binary data is a cryptographic key that somebody wants to copy and paste or email or, heaven forbid, enter into the computer by hand. Doing these things with pure binary data is essentially impossible, hence the base64 scheme. This is one minor thing that the software is going to need. So this is somebody's dependency, and we might as well use it as our test monkey for getting testing figured out. Base64, as well as some of its other kin that you haven't met yet, can be found in util str encodings.cpp and h. str encodings has a lot of other stuff that we don't care about right now, so I have commented most of that out. Doing this gives you a sneak peek at what's coming up soon, while at the same time keeping it easy to recover later when we want it. I'm not going to tediously dissect the functionality of this, because I just don't think it's very important or interesting at this time. Let's just be happy that we have it. But enough of that for now. Let's take a closer look at this test. I have taken the liberty of modifying it a bit. In the original Bitcoin software, this test is just one of many other tests. But at this time, it's our only test. These tests cannot be independently executed. They need a test runner. But getting that figured out is just another layer of complexity, and we'll figure that out later. For now, let's modify the test a wee bit so that we can execute it independently. Boost test dyn link enables us to link against the Boost unit test framework shared library. Boost test main is the secret sauce that enables us to execute this standalone without using a test runner. You can see that I've commented out Boost fixture test suite, as well as its ending macro, Boost auto test suite end. Using these requires more dependencies and more stuff to figure out first. Instead, let's just get started the easy way. This leaves us with a single test case named base64 test vectors. This is defined by the macro Boost auto test case. It's readily apparent that this test case loops through a few inputs, encodes them, compares this to expected values, decodes them, and compares them again to the originals. Said comparisons are done with Boost check equal. You can see that this test includes util, str, and codings.h. Let's take a peek at that now. It starts with this include guard. As you may know, an included file may include any number of layers of other included files. This frequently results in a tangled mess that nobody understands and which may attempt to include the same file more than once. Doing so would cause all the symbols to be redefined, and this is a big does not compute. If you look at this guard closely and think about what it's doing, you can see that the symbols within only get defined once. Starting around line 51, you can see two declarations each for decode base 64 and encode base 64. Said declarations differ by their arguments and their return types. One of them is the more public-facing function that most folks use. But it calls the other more introverted analog, which is best locked away in the back office to do the actual dirty work. Starting around line 181, you can see a template definition that's a dependency of the encoders and the decoders. Feel free to dissect this at your leisure. As you may know, this .h file mostly contains declarations. The actual definitions can be found in the associated .cpp file. Let's look at that now. Fortunately, there's not much else to say here. We have 4 function definitions that match the declarations from .h. Again, feel free to dissect the functionality at your leisure. Okay, now let's compile, link, and execute. Starting in the user local source CoinKit source directory, here we want to compile and link our test file with our unit under test file. Each of these source files have includes, and we need to tell the compiler where to look to find them. That's what the -i dot option is for. We also want to link to the Boost Unit Test Framework library. That's what the -l option is for. Be warned though, the order of elements in the command is important. For example, we have to add the -l flag after the source files. Finally, in the interest of brevity, I've omitted the option to specifically name our executable file. By default, it's going to be a.out. If we do a directory listing now, we can see that. And now the time you've been waiting for. Drum roll, please. Now let's execute our test. Recall that we need to append / to do this. Da-da-da! Looks like it works. Well, that's all for today, folks. Please be sure to come back soon for the next episode of
The CoinKit Chronicles.